Welcome back, guys. Today we're going to be finding inverse functions, focusing on logs in particular. So why do we want to do that? Well, it's going to help us with our next 2 days worth of lessons, which is solving log and exponential equations. So it'll help us with that process. Let's go ahead and get cracking. You don't have to copy this slide. You can if you feel that you need to. It's really just reminding you of what an inverse is. So what is an inverse function? It's basically where the inputs and outputs are swapped. We started off this unit with these tables, right? I let you guys work on these with some calculators in class when we first started. And you see that the tables are exactly the same for this exponential function, this log. The inputs and outputs are just swapped, right? Another little reminder is down here is the graphs. The graph of an inverse is a reflection through this green dotted line. We talked about all that stuff already this year. So like I said, if you want to write it, you can. If you don't, then that's okay. We'll be talking more about the graphs of logarithms next week sometime. Today, just putting it up there as a reminder of how it relates to the graph of an exponential function. All right, guys. So this is something that I would encourage you to write down for sure. It's how you find an inverse. What we're going to be doing today. Give you a moment to copy it, and then we'll talk about it. So inverses, like I said, where the inputs and outputs are switched. So that's going to be our first step on every problem today is to switch the x and y's. That's what makes it an inverse. But then we got to do some algebra where you get the y by itself. And every problem is different after that, and so it's really just a test of your algebra skills. However, there are two key algebraic moves that we're going to be applying today. We're going to look at two types of problems today. We're going to spend some time on logs mainly. We'll hit up a few exponentials towards the end, but when you want to find the inverse of a log function, you need to somehow find a way to cancel a log out. And the way you do that is this thing which we'll call exponentiating both sides. If you start with an exponential function and you want to get rid of the base number, which is something you're going to have to do to get the y by itself, you're going to log both sides. So those two key algebraic moves will be a part of every problem, but there will be some other slight little different things for each one along the way as we go. So let's start off with something basic here. Go ahead and write down example 1. There we go. So I want to start off by switching the x's and y's around, and that right there makes it instantly an inverse. Okay, but we got to get y by itself. A function properly written has the y by itself. So now we got the algebra to deal with. So if I want to get this y by itself, I need to get rid of this log over here on the left side. The way we do that is by doing the inverse of a log, the opposite of a log, which is an exponential thing, right? So what we're going to do is we're going to exponentiate both sides. So what base are we dealing with here, first of all? We're dealing with a base of 3. Now, what do I mean by exponentiate? These, I'm going to rewrite these as an exponent of the base of 3. So, let me show you what I mean. I made the left and the right hand both an exponent of 3, which I'm allowed to do because, with an equation, if you do the same thing to both sides, then it stays equal, right? So all I did was I made both of those a power of the same base. I chose the base, though, that matched my log base. Now, why did I do that? Because we have a rule for this. What happens to this? It's just y, right? The 3 cancels the log 3, and we're just left with y. And I got y by itself. That is the inverse of the function that we started with. Okay, so if you were to plug in 9 for x up here, you would get 2. Down here, if you plug in 2, you get 9. The inputs and outputs get swapped, right? So those are inverse functions of each other. So this is what we call exponentiating here. Exponentiate. So here's one for you. So Vanessa, what's step 1? Good, and that is what officially makes it an inverse. Jalen, what's my next step? Starts with an E. Say it. Nobody wants to say it.
Exponential.
Good. And what base am I going to use to exponential? Good. I couldn't get anybody to say it last block. They all just said raise it to the thingy. That's like, okay. All right. So Maya, what happens over here on the left?
You cancel out the 5 and the y 5.
That's it. That's our final answer. Did you have a question, or are you talking? Oh. Okay. Let's do another one. So that's the basic idea. You're going to exponentiate both sides. However, there's going to be little twists and turns along the way. So let's start looking at some various little things that could pop up. Go and write this one down. Just follow your instincts. You could probably do this. Let's see. Step 1 is what? Now what? Exponentiate. Exponentiate. Yeah, what's up?
Y is already minus.
I don't understand what you mean.
I know. I was just messing with you.
Okay. You were successful. You saw that whole deer in the headlights thing. What's it mean? All right. So we want to get we do want to get y by itself. We're going to exponentiate both sides with what base?
4.
Good. All right. What happens on the right side?
4 log.
So now here's where things are different, because everything up till there was kind of the same. What would you guys have me do here? We still need to get that. Sure. They thought you were going to answer.
Well, you need the same base.
Huh?
Yeah, that's the thing.
Well, you exponentiate with the base that's there. Yeah, you always use that same base. So now, what do we do now to get y by itself? Any thoughts? Yeah.
The 5.
I wouldn't. No, not this time. There are some probably will do that, but not this one. All right. So, what? Nice, good. You could cube root both sides. Now, if this were a free response, I would take that. You would cube root both sides. I'll cancel the 3. Now, I know what my test software does, though, and I don't think they write it like that. I think they do it like this. But it means the same thing. You raise both sides to this reciprocal power here, because when you do that, these cancel. And you got the y by itself. And what's this side going to simplify into? What's x times a third? X over 3, right? X third. So it's the same thing as taking a cube root, but they're just not writing it in the radical format. They're leaving it as a fraction exponent, which means the same thing. But yes, you could write a root. That would be technically true. So why don't you guys try one of these fun ones. I'm going to skip this example for right now. I tried to do 2 examples in my last block, and I felt like it was a little bit much for them, so we're going to just do another example. All right, go ahead and find me the inverse of that one. I'll give you a few seconds. Okay. Let's do yet another. Write down example 3. What would you say we do first here? Okay. Yeah. That's always going to be our first step, right? All right. Take that. Now what? Okay, good. So Did somebody have a different answer? Because this works. I just want to see if someone was thinking something else. What were you going to say? You could change it to 1 over y to the 10th.
Okay.
But yeah, so like a reciprocal power. Okay. Good question. Let me write down. Yeah. So this is one of our rules from Thursday. I believe it was Rule 3. Rule 3 said that you know, if you have a number in the front here, you can slide it here as an exponent. So that's one of our little rules. Now, why would we do that though? Okay, so here's something that we want to be aware of. Before this, every problem we had was just a log, right? There's one, there's another one. There was no numbers outside the log. So we want just a log. When you have just a log, then you can exponentiate both sides. But if you have numbers that are not inside the log, by inside I mean part of the argument, if they're outside of that, then you need to somehow get rid of those first before you can exponentiate both sides. So I'm going to write that here. I'm going to go with the method that you guys just suggested to me. They picked the same method in my last block. That's not what I would have done, though. It's not that what I would have done is better either. It's just what I would have done is I just would have divided both sides by -10 to get the -10 out. You'll get the same answer, actually. But this works. So now I don't have any outside numbers. I've got just a log. And now we can just do what we did last time, which is to exponentiate. So I'm going to use what base here? And then these cancel. And now we raise both sides to what power? 1/10 kind of, but -1/10 because we also want the negatives to cancel. So when you do that, they cancel. Okay, so this -10 cancels out with that -1/10, and we're left with x, -x over 10 is y. This can also be written, as Alyssa was saying, like this. I'm not too sure how you'll see it on your exam. Just be aware it can be written either way. So the purpose of this problem, once again, was to show you if you have a number outside of the log, you need to somehow get rid of it. In this case, you guys chose to do that by moving it to the exponent. That's fine. That'll work. Let's do another one here for you then. Okay, go ahead and try that one.
Put the 10 to the power of
Exponentiating. All right, so there it is. So that one had a base of 10. That was kind of sneaky, right? I remember when there's no number there, that's our base. All right. Now, before we go into exponentials, I want to show you guys one more thing with logs. What example am I on? Have I been labeling these?
Yeah, it's
Yeah, we're on 4 now.
I'm on 4. Okay, thank you. All right, so I'm going to show you something that looks like the same problem, but it's not. Call this one A, this one B. All right. you guys see the difference, right? One on the left has those parentheses, and the one on the right doesn't. Now, the one on the right, you can think of it as having parentheses if you want to. But they won't write it like that for you typically. But the difference between these two problems here is that the one on the left, you're logging. Remember, log's not a number. It's an operation of doing something to these values. So you're logging x plus 4. Over here, you're only logging the x, right? So this 4 is an outside number. Over here, on the left, the 4 is an inside number. Now, on the last slide, we talked about how when you have an outside number, you want to get rid of that before you do exponentiating, right?
Yeah.
If you don't have an outside number, you're good to just exponentiate right away. So because of the way these are set up, on one of them, we're going to just pretty much start off by exponentiating right away. On the other one, we're going to get rid of the outside number first, and then we're going to exponentiate. And the answers come out a little bit different because of that. So let's go ahead and take a look. On this one here, first of all, we always start off the same, right, by switching these around. Now, do I get rid of an outside number first, or do I exponentiate right away here? We exponentiate right away. And what base am I going to use? 10. So this is going to be 10 to the x is equal to 10 to the log y plus 4. And on the right side, the 10 cancels the log. So now I'm left with this. I still need to get y by itself, so what do? Just minus the 4. Now, I can't combine the 4 with this 10, right? Those aren't like terms. So we're just going to put it next to it. And that's our final answer there. 10 to the x minus 4. So that's an example where you have it inside the log. So you just start by exponentiating right away, right? Over here, we'll see what the difference is. So of course, first step is to switch the x and y, right? Now that 4 is not inside of the log, right? So I'm going to start by getting rid of the 4 first. How do I get rid of that 4? Yeah, you're just going to minus it. So on the left, I'm going to have x minus 4. And on the right, I've got log y. Now we can exponentiate. So once again, before I go any further, if there's no outside numbers, you can exponentiate right away. If there are outside numbers, you get rid of those first, and then you exponentiate both sides. Once again, what is my base? 10. So now it's going to be 10 to what power? Is equal to 10 log y. And over here, these cancel. And I have my final answer here. So notice these answers look very similar, but they are actually different. On the left, the 4 is just being taken away from 10 to the x. Whereas over here, the 4 is actually a part of the exponent on the right side. Okay, so you do get different outcomes because of that. So those little parentheses make a big difference because they indicate that there's different things going on there. All right. So I'm going to put 2 problems on the board, and then I'm going to give half the class one, the other half the other. You got to figure out which process applies to yours. The reason I'm doing this, I don't want you guys to take time to do 2 problems because I want to move on to our next one before we run out of time. So log base 5 of x minus 3, and then log base 6 of, I guess we'll keep it the same. Why not? Just make it confusing. Okay, so I'm going to say for Maya, this row, and over, I'm going to have all you guys work on the one over here. And then from this row, Diana, and over. You guys are going to work on the one on the right. See if you guys can get the answer. I'll give you about a minute for it. On the second one, you're noticing there's no outside numbers, right? So we can start by exponentiating both sides. But first we switch x and y, right? So let's go ahead and exponentiate. I'm going to do 5. Whereas I think you were working on the one over here, right?
Yeah.
Now for yours, you wouldn't have done that first. You would have started by adding the 3 first, and then you would have exponentiated. But here we have this, and then you add the 3 afterwards, which means it's not going to be in the exponent. So, good? So we've covered logs pretty good. In retrospect, I wish I was showing you one with an ln, but just remember those have a base of e. The rest of it's the same. Well, maybe we'll look at some when we do some exponential problems. Let's move on to some exponential stuff. Start off with something simple here. Example 5.
Yeah.
Same directions. We want to find an inverse. So okay, so first step is the same. You're just going to switch that x and the y around. Okay? But now here's where the algebra starts to get different. So in the beginning of class, I gave you that chart, right? For a log, you're going to have to exponentiate both sides. But for an exponential function, which is what this one is, you're going to log both sides. Now, what base do you think I'm going to use?
3.
Yeah. So I'm going to do log base 3 of x and log base 3 of 3 to the y. I just put log on both sides. But you have to make sure the base matches the base that you start with. So why do we do that? Well, we have a rule for this, right? When the base matches this number here, these kind of, in a sense, cancel each other out, and I'm just left with what? 1. Okay, that's it. Let's do another one. No, Mr. Baby. Mr. Baby. Hey. All right, so switch x and y, right? Now, I want to log both sides, right? What base am I using? E. My base is E. What does a log look like when it has a base E? ln. So I'm going to ln both sides. Okay? It looks a lot different, but we're really just doing the same thing. Yeah. So what happens over here? What will I be left with? Y over 2. Now what? Multiply the 2 out. We want to get y by itself. So we're going to multiply both sides by 2. I'll put it over here in the front. So these cancel, and I'm left with y equals 2 ln of x. Now you can write your answer like this, but we can also write it as y equals what? Remember our little rule from Thursday, right? You could take that number in the front, change it to an exponent. I'm not sure how it would appear, but just know that both of those are possible ways to write your answer. All right. Let me throw one more at you. Okay, step one, change the x and y. Now what? Good, right? We want to have just this before you log both sides. You want to get rid of any extra numbers, right? So we're going to start by minus. It's the same kind of idea as we have with the logs. Outside numbers, get rid of those first. So let's do that. Move the 5 over. Now what? We're going to log both sides. What base am I going to use? 3. Now I'm going to put this whole thing in parentheses because I'm logging that whole thing, right? If you just put log x minus 5 without parentheses, then it looks like you're just logging the x. But I'm really logging the whole thing, x minus 5. And then what happens over here on the right side? All right, so I'll put up a couple practice problems you guys can mess around with until the bell rings here. Start you off with some easy ones. We'll work our way up. No, Mr. Bailey.